started here. So I did work with a student over the summer who was able to pass the class, but theirs seemed to be a little bit easier relative to yours. So, okay, the first one's pretty straightforward. It says, what's going on right there? Is that a min or is that a max? This is a max. It's a peak. It's like if you've ever been hiking. So hopefully there's a max something there in the drop
Okay.
down.
Yeah, the absolute max.
There you go.
Okay.
And please,
Okay.
oh, this one you can't check as you go. So I guess we'll have to wait till the end. All right.
Okay.
Excuse me.
Sorry, I should know more.
Are you good for us to continue here?
Yeah.
All right. So X1 is like down here, right here at this bottom here. That is an absolute min. It's the smallest value of them all.
Okay.
And then it's kind of hard to see on your maybe on your side, maybe it's easier in the graph. It looks like X4 is the absolute max. So it's the highest point. Okay. Now we talk about X2 and X3. Like X2 is a peak. It's higher than the points around it, but it's not the highest point. You're making up, oh, I'm at the top, and then you realize there's more to go. So it's what's called a relative max, because relative to everything around it, it's the biggest. And then X3 is a relative min because it's lower than everything around it. Does that make sense?
Yeah.
Yes, no, maybe.
So if it's relative, would it be neither absolute extreme?
What are in the drop downs? I didn't see that when you were
Oh no,
when
you're
you're
good. It's absolute max, absolute min, and then neither absolute ex extreme.
yeah, so
Extreme.
these are both neither.
Okay. Okay, that makes sense.
Another thing I should have mentioned, I didn't know you guys were both in the class, is you guys could always do a session together where, whatever you guys want me to work on, I'll help with. Like it's not limited to one person.
Okay.
If that ever was helpful.
I can, yeah, I'll talk to her about that.
All right. So here is kind of this is the question you're gonna get in a test or a quiz. Okay. So the first thing you have to do is you're given a function and it's got what's called an A and a B, like two endpoints here. So you have to evaluate at each of the endpoints. So if you have a calculator, I would recommend, trying to work this out with me, getting comfortable with the calculations, but I will do them as part of the lesson here today. I'll leave that up to you. Decide if you want to be involved. It's also a good check because sometimes I do make mistakes. Um,
Okay.
that's
So
when I,
for this, when it's giving the domain, that's what we put in for X.
yes, you're putting
Okay.
those two x values in. So it's like 1/3 -6 cubed plus 1/2 -6 squared minus 20 times -6 plus 2. Again, like I like you to check because I do make mistakes. Lately I've been very bad about making mistakes. Okay, so this one says to round to two decimal places. That's important. This one ended up being minus 343.83, like that. All right, that's kind of thing one. All right. Thing two is you have to be able to take a derivative of this, which sounds like it's going to be the challenge here.
Yeah.
Do you remember anything about derivatives?
No, that's the one thing
Okay.
that I just cannot pick up on.
Okay. So the let me grab a quick snip of this. I'll spend a little time on this one. The other ones I can just do for you, but
Okay.
that's the only way you're going to, the next part of the course really relies heavily on your ability to take derivatives. So
Yeah,
there's
I
what's
was
called
gonna
the,
maybe try to do like a separate session with you, just learn
sure.
like learning about derivatives.
Yeah. So the most basic rule is that the derivative of something where it's x to a number is the derivative is you bring the number down and you subtract one from the exponent. Okay. So for this this x cubed right here, you bring the number down and you subtract one from the exponent. But you also have to bring this constant down like that.
Okay.
So this simplifies 1/3 of 3 is 1. So this becomes just x squared
After all of that?
after all of that. Yeah, because 1/3 of 3 is 1. You don't write the 1. 3 minus 1 is 2. It just becomes x squared.
Okay, so it's not 1/3 times 3x, or is it,
It,
or
it
is it?
is, it is,
Oh,
but it
sorry.
reduces, 3 over 1 reduces to just x squared, just 1x squared. Is that okay?
Yeah, sorry. I'm just writing it down.
Yeah. One of the limitations of the format is I can't read your body language, so I have to like a lot of questions, and I
Oh no,
apologize
that's
if it's
okay.
annoying.
No, it's okay. I don't care.
All right, so for x squared, the derivative of x squared is 2. Bring the exponent down x to the 2 minus 1, and then this 1/2 comes down.
Okay.
And so that becomes just x to the power of 1, 1/2 of 2.
And this is, never mind.
And then the last, there's some specialty cases here of this. So like the derivative of a constant times x is just a constant. And that applies to this third one. The derivative of that just becomes minus 20. Uh, and then the last one, the derivative of just a constant is 0. So if it's just a number like 2, it becomes just 0.
Oh, okay. Okay. So then would we just put nothing there, or we put 0?
Yeah, you don't put anything, just you
Okay.
leave it. So the next thing is you do set the derivative equal to 0. And this is where your prerequisite courses come into play. You have to remember how to factor this. You have to find two numbers that multiply to -20, but add to +1. So this becomes x plus 5, x minus 4. And then you set these each equal to 0. So x ends up being -5, and x is 4.
Okay. Okay. I got it.
All right, now you have to check and see, are any of these numbers in the original intervals? The original interval was from -6 to 5. So
Mhm.
these are both in that interval. So you have to check them both in the original. So you go back up here and you check 4, -5. So you have to find f of 4 and f of -5. Those are what are called the critical points.
Okay. As well as -6 and 5.
Yes. So you always check the two endpoints that you're given to start with. And then you also have to check any critical points. So
Okay.
4 becomes -48.67. And then -5 is 72.83. All right, so there is a max and there is a min. This is the min and this is the max. So the way to answer this, it's sometimes that's like even as difficult as figuring out. So the absolute maximum is 72.83. So you're gonna hit that first radio button, and it occurs when x is -5. And then the absolute min is -48.67 when x is 4.
Oh, okay. And okay, that makes sense.
Yeah, please ask your questions. I mean, I'm not going to go into great detail because I don't think you want it, but I'm happy to answer any questions, to
Okay.
make this more doable for you. But
So we plug in the domain and then we plug in what we get after we find the derivative.
yes,
Okay.
exactly. Take the derivative, set it equal to 0, get those two x values, put them back into the original function.
All right.
I mean, in principle, it's not that difficult, but it's
Yeah.
it's a lot of work.
Yeah.
Right. And moving on here to the next one here. All right, so the first thing here is to evaluate the function at -6 and 6, the two endpoints. So that's -6 to the power 4 minus 50 times -6 squared plus 4 like that. Do you have a TI 8384 available? Not necessarily today, but
Yeah.
do you have one available? Okay.
Mhm. I have, yeah, I have one.
If you ever have any questions on how to use that, I do have a virtual TI 8384 that I can show you if you're unsure about
Okay.
any of the calculations.
Okay.
Um,
Thank you.
right, so that's that. So this isn't super helpful because it just says they're the same place. One's
Okay.
right.
What
So
does
now we
that
got to take it.
mean? Anything?
Well, it's like there's 2 points and we don't know what happens. We don't know if it goes up and down or it goes down and up. Like we don't have any idea. So it's basically useless. So
Okay.
the next thing is to take the derivative of this. All right. So the function here, let me grab a snip of that. All right. So derivative here. Any idea what the derivative of x to the fourth is?
No.
Okay, so you bring the exponent down, and then you subtract 1 from the exponent. Does that make
Okay.
sense? So it's 4, it becomes 4x to the power of 3. For the second piece, x squared, that x squared, you bring the 2 down, and then you subtract 1 from the exponent.
Okay.
And you multiply the 50 by the 2.
And so you always subtract one of the exponent if the x has.
Exactly.
Okay.
Yes. The derivative of a constant 4 is 0. So you just don't write anything. Questions on that? Thoughts on that?
No.
All right, so you set it equal to 0.
Okay.
And this is where, like, if you had a 80 T84 plus, I think it might have a solver for something like this. I don't really remember, but you can factor to solve. You factor out a 4x from both, and you get x squared minus 25. And then you have to be able to set both of these equal to 0.
Okay.
So you're going to set 4x equal to 0 and x squared minus 25 equal to 0. Do you remember how to solve either of these equations?
Yes.
Okay.
You divide by 4, then move the 25 over.
Yeah,
Add.
and there's two solutions to the one on the right. It's plus or minus the square root of 25.
Oh,
So that just be careful that you make sure you write down both of them. So it's plus or minus 5. And just like the previous problem, you have to check to see, do those numbers, are they in the interval?
mm, yes.
They are. So you're okay. All right, so now we have to check each of those back in the original. So we have to find f of -5, f of 5, and f of 0. So f of -5 is -621. F of 5 is -621. And then 0. 0 is 4. So when you look at these 5 numbers, which is the biggest, which is the smallest?
The biggest is 4.
Yeah, that's your max.
The smallest is 621.
Yeah, those are your mins. So it has 2 mins this time, or 2 places where it has a min. So it probably says a comma somewhere. All right, the absolute maximum is 4 when x equals 0. The absolute minimum is negative 621 when x equals negative 5, comma 5, like that.
Okay, so so you include both. Okay.
I think it's somewhere it would say, I think I cut it off, use comma to separate answers. Any questions on that before we move to the next one?
No.
Okay. All right. So for this one, you want to try the 2 endpoints.
Okay.
You want to try f of negative 2, f of 0. All right. So f of negative 2
Mm.
and f of 0. So for negative 2, it ends up being 3 over 2. F of 0 ends up being 4. All right, and now to take a derivative. So the derivative of this is more involved. Um,
Oh, oh,
Probably a good chance to review some of your derivative rules. Um, you only have to know them for this course. I mean, you can forget them otherwise. Uh, you'll never be asked to take a derivative. Um, so let me I just put this in the chat here. This is like a reference sheet that'll be useful for the rest of the course. You might consider printing it out or having screenshots of it
okay.
available for you. But in terms of taking the derivative here, um, it's there's this idea of there's a top function and a bottom function. Can you tell me the derivative from what we talked about so far of 8? 8 is a constant,
It would be 0.
be 0. And then derivative of x, what's derivative of x?
Um, would it just be
So it's like a constant. So the rule is a
oh,
derivative
so
of
it'd
a
be 1.
constant. Yeah, it's just the constant. So just 1. How about g prime here? What's the derivative of this?
Um, it's the same thing.
There's
1.
a negative in front this time. So what number is in front of x?
Oh, -1.
Yeah.
Okay.
So the derivative rule for a quotient is you take the bottom function times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Okay,
Okay.
so now it's just putting those pieces in. So g is 2 minus x, f prime is 1, f is 8 plus x, g prime is -1 over g squared, which is 2 minus x squared. Now you do have to simplify the top because we have to set it equal to 0. So to do that, you can see that the negative on the right here cancels with that just becomes positive. So your top here is 2 minus x. That 1 just multiplies in and goes away. This goes to a plus 8 plus x. And you can see that the x's cancel and you're just left with 10 on the top. Does that look okay to you?
Yeah. Did
All
you
right.
scroll up just a sec?
Sure, sure.
Oh, yeah, right there, so we can get a picture.
Yeah, I'm gonna send this to you at the end as a PDF,
Oh,
a
you do?
graphic.
Oh, right. Okay.
Yeah, and then I'm screen recording as well, so you'll have all this. But take notes or work them out with me if you want. But yeah, I'll send it all to you.
Okay. Yeah, thank you. Taking notes.
One of the reasons it might be good for you guys to do a joint session is like you might have like exactly the same problem in your quiz, or maybe like hers is like, 6 plus X and 3 minus X. Like they're basically the same. We can do them
Okay,
at
yeah.
both side by side there. Okay.
You know,
So the issue, go ahead. Question. I'm gonna keep going here unless I hear
okay.
otherwise. So there's no critical points because there's no place where the top equals 0. So we're basically done. Okay. These are the only two places to consider.
Okay.
So this is the max and this is the min.
Oh, okay.
The absolute max is 4 when X is 0. The absolute min is 3/2, uh, which is maybe you want to put in 1.5. And then that's at a -2.
Wait, absolutely.
It's two questions. It's like, what is the max?
Okay, okay.
Where is the max?
Okay. All right. I got it. Thank you.
All right. Okay. Um, Let me grab the next one. The lessons are 50 minutes, so we'll be going right up to 3:50-ish. Get as much
Okay.
done as we can. Of course, I don't want to waste your time with what we're doing. Okay, total profit is given by this equation. Find the number of hundred thousands of tires that must be sold to maximize profit. So in order to maximize profit, you again have to check the endpoint, which is 5. So you really want to find P of 5. So you're going to put 5 into this equation here. All right, so I'm going to just quickly calculate that. If you're really good at graphing, that's one way to do these problems that will save a lot of time, but you got to be really, really good at graphing. And
Yeah,
depending on what you're,
um, I like kind of know, but the calculator, I don't know. I don't work it too well with graphing.
yeah, yeah. So this is probably gonna be your best path here. So the next thing is you got to be able to take a derivative of this. So the derivative is minus 3x squared plus 18x plus 120. And then you have to set this equal to 0. And this is again a place where maybe if you were comfortable graphing, you might find it faster than factoring.
Okay.
This factors into x minus 10, x plus 4, like that. And you set each of those equal to 0. You get x equals 10 and -4, but it has to be in this interval 5 to infinity. You can see that the -4 is excluded.
Okay.
Hopefully that's reasonable, clear, all that stuff.
Yeah. Wait. Okay, yeah.
All
So
right.
what does that mean?
So what now, that critical point, we have to put back into the original. You have to find P of 10. And we're going
Okay.
to find that that probably is bigger than 500. And it is 900. So the maximum profit is, and we got to be careful with what it actually says here. So see, this is the total profits in thousands of dollars. They're up
Yeah.
there at the top. So that
Yeah.
means what goes in this box right here is 900,000.
Okay.
But the second box says 100,000 tires sold. It's 100,000 tires sold because it's already in the right units. It's just kind of an oddity of this question. Like one of them is in the wrong units and one is in the correct units.
Wait, I'm sorry. Where did 900,000 come from?
So we got 900, but it says the profit is in thousands of
Oh,
dollars.
that's
So
900. Sorry. Okay, yeah.
yeah,
Okay. When 500 wrestle. Oh no, 10. Okay.
that okay?
Yeah.
All right. I generally don't read these words and just go right to the thing that's there.
Okay.
You can read it if you want, but it's essentially the same type of problem. You have to evaluate at the endpoints. You have to figure out what is f of 1, what is f of 12. You have to take a derivative like we've been doing, and then figure out, where's the minimum. So let's do it. Let's evaluate when x is 1.
So we just plug in. Okay.
Exactly, yes. Put that number in for x. It ends up being 8.5. And then for 12, this one ends up being 20 over 3, which approximates to about 6.67. Right. Any questions on that?
No.
All right. Now the derivative here, you can take your derivative without the quotient rule because you can actually divide each of these by the 2x. This is what's called a rewrite step. No calculus yet. And then from your previous courses, you're supposed to remember, oh yeah, I can cancel an exponent there. The 16 and the 2 cancels to make 8 and 1. So the rewrite of this is that it's really 1/2 times x plus 8 times 1 over x. Take a look at that and see if there's any questions on how I did that. That is just the rewrite, no derivative yet.
No, no, I get it.
Okay. And then the kind of a little other thing you can do here, what a lot of students do is they like to actually write the exponent and then 1 over x is really x to the minus 1 power.
Okay.
All right, so now your derivative. We're finally ready to take a derivative. When it's a constant times x to the power of 1, it's just the constant. When you have an exponent that's not 1, you bring it down, so you times -1, and then you subtract 1 from the exponent.
Right.
So this becomes x to the -2 power. Then there's a negative. So this is all simplifying now. 1/2 minus 8 x to the -2. It becomes 1/2 minus 8 over x squared. You're setting this equal to 0. So to solve something like this, you're going to move this to the other side of the equation, this minus 8 over x squared. So you're going to add that to both sides. So you have 1/2 equals 8 over x squared. Now you can cross multiply. Saw
Okay.
that in the previous course, kind of butterfly thing here. So x
Uh-huh.
squared times 1 is 1x squared. 2 times 8 is 16. And then there's two solutions. You take the square root of both sides, but it's a big but, maybe not a good thing. Uh, it has to be in the domain. Like, are both of those in the domain? That's where you got to go back to the original. And like, are they both in the domain? No, only one of them is
Okay.
4. So you have to now find f of 4. So you exclude, it's 4 and -4. You
Is that
exclude the
because
negative.
this was the answer? So now we're trying to find 4.
Yes, yes,
Okay. And because -4 doesn't fall in that, we don't do that.
that's right.
Okay.
That's right. Any questions, thoughts on that?
Um, no, I'm trying to plug in 4.
So that's 4. That's the X value, and then this is the Y value. They just happen to be the same in this problem.
Oh, okay. Like the months and the percent is both 4.
Yeah, it just happens to work out that way. I mean, one of the things I was trying to tell Anna is that the like these are patterns. So like if you were to get this problem again, these two numbers would probably be the same, like
Okay.
whatever they ended up being. I
Okay.
mean, not as a like it doesn't always work, but
Yeah.
maybe it
Because
would
you
work.
can scroll down for just.
Yes, yes.
Okay. And that cross multiplication, did that give us the.
They gave us the 1x squared equals 16.
Oh, it gave us 4. Okay. Yeah.
The 4 and the -4.
Okay. Perfect.
All right. Any follow-up to that before we continue? All
No, yeah. We're good.
right. All right. Blah, blah, blah. There's some equation here again, and the you should check the endpoints. Like,
Okay.
I don't know whether it will or won't work at the endpoints, but you like as a good habit, what's called a best practice, you should probably check the endpoints first before taking a derivative. And that will help. I'm just putting this into my calculator on the other screen.
Okay.
Plus 4765. Didn't why doesn't it do that? All right. All right, it's x minus x cubed plus 7.5 x squared plus 198x plus 4765. Okay, so that is 5817.5. And then for 20, it's 3725. So the maximum right now is this number, but we'll see if we get a better number when we take the derivative. So the derivative here using
Okay.
power rule is minus 3x squared plus 15x plus 198. And then you're supposed to set this equal to 0. You can factor a -3 out of everything. I think, yeah, that does work in the last one. Plus minus 66. That looks like it's going to work. Um, X minus 11, X plus 6. You set the X terms equal to 0. And so you get X equals 11 or X equals -6. So for the 11, that's the one to try because this one's excluded in the domain. So we're going to go back and try f of 11.
Okay. And then when we like input the answer for the derivative or the f(1x),
Oh, yeah. Sorry.
are we doing the full that one? Okay.
That's what goes into that part. Yeah, please ask because sometimes I get all like excited about working through these and I forget you have to actually answer them.
No, it's
Um,
okay.
yeah, please. So it occurs when the water looks like 11 degrees Celsius.
Okay, so okay. Okay.
Questions on that?
No.
All right, moving along. All right, for a certain automobile, they have this equation. And again, they give you this interval. So you have to find m of 30, m of 60, like that.
Okay.
And it's not a trivial task to just put in the calculator. Like it's easy to mess that up. So just
Wait.
if you have
Um,
time, if you have the desire, maybe try that out on your own at some point.
the calculator?
Yes.
Okay.
Just
For
make
now,
sure you're not, you've got some idea of how to do it before you get to
yeah,
the test.
no, I do. I've been writing it down and then
All right, so
fine.
30 is the 23.1, 60 is the 26.7. So you can see right now, it looks like that's the min and that's the max.
Okay.
All right.
Is there further work or
Yeah, take a derivative.
oh, okay.
These are very repetitive.
Okay,
So the
yeah, it seems
derivative
like
here
it's
is,
all like the same for each
yes.
problem.
All right, so this one you set equal to 0. It ends up being 1.47 over negative 0.03, which ends up being, sorry, 49. So you have to then find m of 49.
Is that negative 0.03?
Yes, yes.
Okay.
And this is 28.515. So you can see that that is max. So the
That's
absolute max is
and
28.515
then the min
and
is 30, 23.1.
23.1, yeah. 49 and 30. Which is actually a little surprising. Usually the slower you go, the better fuel economy you get. Uh, yeah, I don't make the questions. So
Yeah.
any questions of that? 'Cause we're about to transition to some application problems.
No, that's
These are a little bit different. They're not like the ones we've been doing.
okay. No.
All right. All right. So it says here, find two numbers that maximize the product right here,
Okay.
but they have to add up to 190. And so they're stepping you through it on this one. They're saying like, here's all the steps, and then you're supposed to somehow know to do these for the rest of them. You're
Okay.
solving this first equation for y. So you can solve it for y by subtracting x from both sides. So y ends up equaling 190 minus x.
Okay.
That's what goes in the box there.
Oh, it's just in a quick. Oh, yeah. Okay.
Okay, we'll get to the next box here shortly. All right, substitute the result from part A into P equals XY. They're saying put this in for Y. So your P is equal to X times 190 minus X. I don't know if you have to simplify, but we might as well do it. You distribute that X in 190X minus X squared. So I believe what it's looking for is everything in this box here.
Oh, like the P also and
Yes, P as well.
okay.
Unless the box you would know to exclude it if it said P equals and then the box.
Okay.
Here it
Okay.
wants the whole thing. Any questions on that? Anything like that?
No, not so far.
All right. E. All right. I'll be right back. Just need like 10 seconds. Just gotta turn on something. Right.
Okay.
Okay, it says to find the domain of P. So it really goes back to the questions, the original question here, which just says two non-negative numbers, which means they could be zero, but they have to add up to 190. So the way to do it is to be like, okay, well, if x is 0, y is 190, and if y is 0, x is 190, there's your domain. The domain is everything from 0 to 190.
Mhm.
0, comma 190, and use these brackets to indicate that you're including the endpoints.
And that was from,
That's for C.
I know the 0 came from,
It's this idea that if x is 0, y
oh,
has to be 190 because they have to add up to 190. And if y is, or if x is 190, then y is 0. Basically, trying to figure out the biggest and the smallest values they could each be,
okay. And we're using brackets, not like
not
parentheses.
parentheses, because it's included. Like it could be 0, it could be 190. All right, next thing is here is to take a derivative. You're taking a derivative of this 190x minus x squared.
Okay.
Apologize for the scrolling. So dp dx, that's just derivative notation. The derivative is 190 minus 2x. That's what goes in this first box.
Is that different because it's the dp over dx?
Yeah, so there's a lot of notations for derivative. Basically, they're just saying take the derivative is p is a function of x. So it's the y variable over the input variable or the output over the input.
Okay.
All right, and then the next thing is to set it equal to 0. So you get 190 equals 2x, x equals 95. That's the second box there. And then in these application problems, like we're looking at, the next few will be like this. You are it's always the wherever the derivative is 0. That's where you're looking. So the answer to the last part is always going to be at that whatever x value you find with the derivative.
Okay.
That's the shortcut, sort of.
Okay.
And you have to actually put that back in to the original. So P, if you recall, P was 190x
Just the
minus, sorry,
original equation.
yeah, minus x squared. You got to put that x value back in.
Okay. Oh, p. Okay. 190 x.
Why didn't that work? What did I do wrong? Um,
It's
okay, I got 9,025 for that.
okay. Me too.
Fantastic. All right, so that's probably just as good a place as any to stop. We are out of time for today.